see what we have today. Okay. Number of equivalent down pairs. Given a list of integers or dominoes, man, I'm doing dominoes for the last 3 days. Dominoes at I is A, comma B is equivalent to dominoes. Given a list of dominoes, if you have equivalent dominoes such that either the first number is equal to the first number is equal to the first number of another domino, or the first number is equal to the second number of the domino, and vice versa. That is one domino can be rotated to equal another domino. Okay. Return the number of pairs ij for which 0 is less than I is less than j domino's length for their equivalent. Okay, return the number of equivalent pairs. So here 1, 2, and 2, 1 are equivalent. And here 1, 2, 1, 2, 1, 2. The number of pairs are equivalent. So these are equivalent, that's equivalent, and that's equivalent. Okay. Interesting. So there's only 36 possible pairings, I think, like 1 through 6 versus 1 through 6. So I can do a count of the possible pairings. And then do a calculation based on the number of the frequency which pairing occurs. You do like a n squared divided by n times n plus 1 divided by 2 to calculate the number of possibilities that a certain frequency can be paired. Okay, so let's try that. So let's say the frequency, how to store the pairing. I can store it as a tuple, but if I were to do it more efficiently, I could possibly store it as a single value. So for instance, like 1, 2 computes to be 1 out of 36 somehow. So 6 times the smaller number plus the bigger number. Yeah. Okay, so it's so 6 times the smaller number plus the bigger number for actually I'm not sure if this works for ij in dominoes. Print ij. I don't think this works because I don't think it knows that I can just assume that it's just no, it does work, huh? Okay. Okay, let's say there's a frequencies and it's going to be 0 times 36. And for each ij in dominoes, I'll say ij is going to be the min of ij and the max of ij, just to make it smaller and larger. So I is the smaller one, and then I'll say frequency of 6 times. Actually, I kind of want it to be minus 1 because I don't want the values to be from 1 to 6. I want it to be from 0 to 5. So 6 times I plus j is increased by 1. Okay, yeah, so the frequencies increase, and then for each index in the range of 36, the answer will increase by how many times you compare that frequency. So like if you have 3 things that are the same, like in case 2, the number of pairs would be 3 times 2 divided by 2. N times n plus. It should be n times n plus 1 divided by 2. 3 times 4 is 12 divided by... No, that's wrong. So if you have one thing, it should be paired 0 times. It's n times n minus 1 divided by 2. So the answer is equal to plus equals, actually, I think I can just do for each frequency and frequencies. Answer plus equals frequency minus 1 times frequency divided by 2. Okay. That's out of range. What values do I have here that's out of range? Oh, dominoes can be up to 9. Holy what? What type of dominoes are these? Okay, dominoes can be up to 9. Okay, so that means it's, it says 6 times 6 is 9 times 9, which is 81. And this should be 9 times I plus j. Okay, 92%. It's not bad. I wonder if I can do this faster. Do 1 times 2. Yeah, it feels like there way I can do this one without doing a min or max. You have two numbers. Is there a calculation to perform that gives you the smaller number? If I say I have a 5 and a 2, 5 minus 5 plus 2 5 plus 2 divided by 2 gives you your average. So it's going to say 5 plus 3. So it always gives you an average if you do the if you do sum divided by 2, it always gives you an average. And can guarantee so each time you pair something, so you can increase the frequency by 1, but you can also increase the answer by how frequent it was, right? I think maybe you can do without the second loop, because if you have a certain value, the first time you see it, you can form 0 pairs. The next time you see it, you can form 1 pair, which is the number of things that you saw previously. Next time you see it, that extra thing can form 2 pairs. So maybe you can just do I don't know if this is any faster though. You can do maybe like answer plus yeah, I don't know if it's any faster. Answer plus equals frequency at 9 times I plus j, and then increase that frequency. I know that, I'm pretty sure this works. Whoops. Answer plus equals frequencies. Okay, I think that works. But I mean, it maybe saves a pass. I don't know if it's any faster. Yeah. And it's possible I can use a default dictionary here. Let's try default dictionary. I don't think that's any faster. Yeah, it saves memory because you don't have to allocate 81 spots for combinations that you need, especially if it's a small array domino. But it's slower because I think arrays are just faster. Okay, so let's go back to the arrays, screw the memory. How can I beat this? Every ij every domino let's see, calculation to get minimum of 2 numbers without ifs. Is there a possible thing for this? Without branching. Use XOR and a comparison operator. Oh, but why exclusive? This is exclusive and? No, this is XOR. Use XOR. Minimum of x and y will be y on some machines valuing x less than y as 0 1 requires a branch instruction, so there's no advantage. Use subtraction. Int min. We know that if the minimum subtraction is shift. What the? I was really hoping for something better than this, but what is this? Holy shit. Some grants under various methods no condition and restriction exists. Thought there might be a fancy computation that you can use, but this seems a little too complicated. I mean, I guess maybe you could do something where lesser is equal to the min of ij minus 1, and the larger, lesser, less and more. What's the opposite of lesser? Smaller, and then you can do bigger is equal to the sum of those two minus the smaller. That saves one if statement, I guess. Maybe I can. Okay. Let's say this is AB. And min is this. And smaller is just I and J. I guess that maybe saves one if statement. If it worked. Minus 1. Minus 1. Is it minus 1? I think it's minus 1. Still out of bounds. So it's the smaller one. Okay, so how is this working? A is the smaller. And I want the smaller one to be subtracted by 1. And if I do the sum of the two bigger ones, they have an addition of plus 1. So it's plus 2 that I want to get rid of. Minus 1 over here. But this is already too small. So this is plus 1, so this is actually minus 3. Oh my god, convoluted logic. Okay, that didn't work. Is it because of this thing? No. I mean, I could try. Excuse me. I could try to see if that. That didn't help at all, huh? So now the memory improved. Do a hash? No. Do. Huh. What if I did something where it's just for every dom, I say I is the min of dom and j is the max of dom. I equals min of dom minus 1. Gosh damn. I comma j max of the domino minus 1. Okay. Yeah, I am. How is this performing worse than my original one? Oh, it's because using an array comparison rather than just two integer comparisons. I guess if you pass an array, it's probably harder to find the min or max. The array, maybe it tries to go through all the array value. What the fuck? How is this? What? This is worse than my first one, but it's the same as my first one. It's literally the same. Okay, I'm done. I'm done. Enough goofing off. Okay, so summary. This is so find a way to count the most frequent or the frequency of each kind of domino pairing. You could use a tuple as the key to a dictionary. I chose to the or here or in the above used a equivalent single value for each pairing where the single value is equal to 9 times the smaller plus the bigger. It's basically, it's like mapping, this is like mapping a tuple yeah, so there's a map which will be a unique mapping of each domino to the range of 0 to 80. Note here that domino is 1 through 9 in this problem instead of 1 to 6, and converted that to 0 to 8 for smaller, larger values. So after you do that, after getting frequency of each domino, the number of pairs based on that can be formed based on that domino is f times f minus 1 divided by 2. This is just common kind of number theory / combinatorics logic. Combinatorics logic. Time complexity is going to be, and obviously you go through frequency, data structure, and add to answer the contribution of each frequency. Okay, that's obviously this portion here. This is a single value mapping for tuple is 9 times I plus j. Alright, time complexity, this is O of n for single pass through array, through Domino's array to get frequency. And space complexity, this is also, technically this is O1 or O of V, where V is the range of values that Domino's can encompass. So in this case, it's like, technically if the Domino's were 1 through like 100, then the frequency mapping would be bigger.